Welcome, everybody. It's June 14th, and we'll be continuing our journey through the Fuller explanation, Amy Edmondson's book. And we'll be covering or finishing chapter 9 this evening. So, Richard, how are you feeling? What are you looking to take away from today?
How am I feeling? Well, quite good. I was on a different call group this morning, the Worldwide Weavers, and we had some really good discussions on the whole question of consciousness, and part of that is tied into a series that I'm connected to that's all about invisible, or about the convergence of consciousness into its own sort of science and how it relates to matter and the struggle we all have in trying to understand consciousness as something that could be sourced somewhere, could be measured, all the kinds of things that suggest that we keep trying to turn something like consciousness into matter in order to explain it or understand it, when those who are now working more openly with consciousness keep trying to say, no, it's not that, it's its own whatever. um, and we can't find a better a way to understand it through something that it isn't. So it was very enlightening, very connected to the Fuller explanation kind of book. And the thing that I'm really becoming more intrigued with as I listen to different groups talking about the emergence, if you want, of consciousness and what is it and how do we understand it, that an awful lot of what they talk about sounds very similar to what we discuss in our dialogues about Fuller's work. And yet I have yet to hear anyone mention his name or mention that he was an early thinker that was bringing us into, well, not bringing us into, but bringing us sort of beyond the traditional classical physics and sciences of the pre-20th century. So it's intriguing that all of what Fuller talked about is now being dinner table conversation amongst scientists, and yet there's no recognition that that he might have sort of broken the ice for these kinds of discussions back in the tens and 20s and 30s. So, Joe, how are you feeling, and what's your expectations for this evening?
I'm feeling pretty good. Had a little bit of a long day, but not, I mean, it was a good day still. Got to spend time with some very dear friends, and that's always a fortunate experience. Yeah, it's interesting. I know we talked about the philosophical differences between materialists and non-materialists, and I think that I think that sometimes is just an example of how people need to be able to have conversations, and how that there may be philosophical differences, but then how do you make the world work for 100% of humanity? And so that's, I always find those consciousness questions to be intriguing. But I also find them at this particular moment in time to be very important, how to differentiate ourselves from what is just computational power and artificial intelligence. What is it that makes us uniquely human is also an important question to ask. so that as we have this thing that is developing rapidly, and that is demonstrating certain types of behaviors that would, not necessarily always be pro-social. What is it that separates us from other species, and is kind of that differential is important, but also kind of examining different points of view, and embracing different points of view. So, but yeah, I agree. It's good to see that Bucky's work is becoming validated. As far as this evening goes, I think coming back to the isotropic vector matrix is going to be, we're going to be concluding chapter 9. And I think that that's actually an important topic that, we covered in some detail, and we also covered it in detail on Wednesday. Unfortunately, I couldn't participate as much as I would have liked on Wednesday's call. But because of connectivity issues primarily. And so, yeah, anyway, appreciate you bringing that up, Richard, because I do think it's one of those examples of not an either or, it's a both and. So I guess, Steve, are you there? I guess Steve is not going to be there. So
he's gone dark.
He's gone dark. So with that, yeah, I do appreciate you bringing up the questions of consciousness lately, though. It's I think that this is an important thing to explore as we go forward, and to continue exploring, but to look at it from all different angles is really, like anything else, important, so that we incorporate everybody's. So we're going to start with framework of possibilities. That's where we agreed to leave off. Is that correct, Richard?
Yeah, that's where I would say is a reasonable place to start.
Are you able to see my screen? Ooh, are you able to see my screen?
Yeah, I can.
Cool. All right. I mean, we can take turns reading.
Sure.
I can start us off, and then we'll go from there. The Isotropic Vector Matrix gives us a description of the symmetry of space. We can think of this matrix as a framework of possible directions and configurations of ordered space, or more simply, as a frame of reference. It is a network of vectors specifically suited to model nature's eternal tendency toward equilibrium. Lines are forces, length is magnitude, and all is in balance. The IVM weaves together a number of synergetics ideas: minimum system of universe, vector equilibrium, both exhibiting 4 planes of symmetry, 12 degrees of freedom, complementarity of octahedra and tetrahedra, space filling and stability, exclusively a product of triangulation. In so doing, it sets the stage for an energetic mathematics and systematizes further investigation. The IVM also provides an alternative to the XYZ system absolute origin. Keep coming back to that. That's one of your favorite topics there, Richard, is looking at that system. So every vertex in the IVM can be considered a temporary local origin, which is reinforced by Fuller's use of the concept of systems. is consistent with the requirements of describing scenario universe. All points in universe are inherently centers of a local and unique isotropic vector matrix domain. And that's a synergetics reference 537.11, I believe. So, and there can be no absolute origin in a scenario. Finally, by describing such a wide variety of ordered polyhedra and thereby clarifying the relationships between different shapes, the IVM supports Fuller's concept of inner transformability. Countless potential shapes and transformations can be systematically represented within this omnisymmetrical matrix. It is a framework of possibility. Any initial comments or specific?
Yeah, I go back to the first one or two sentences, and in talking about the frame of reference and the notion of ordered space. So what I'm looking at when it talks about the network of vectors situated to model something, in other words, to model nature's tendency towards equilibrium. So my first pause is on the word equilibrium, and my own understanding of equilibrium from a chaos theory point of view. I would substitute, or at least consider substituting, the word equilibrium with the words far from equilibrium. And then it goes on to talk about lines or forces, length is magnitude, and all is in balance.
Mm-hmm.
And I would substitute balance with dynamic balance or dynamic equilibrium. So that's an interesting sort of reflection on the way she's writing the notion of equilibrium and balance. And for me, equilibrium is the that idea that the inner and outer forces are sort of equalized, and so your notion of balance is a static notion. That's what you get for nothing. And that's what I was learning to think differently when I got introduced to the chaos theory literature, to think of equilibrium as, if it's stillness and static, it represents the the flat line on a heart monitor. In other words, it represents death. And far from equilibrium represents a condition of robustness, and, well, it's a condition of robustness, but it entails stretch and fold. So it really entails the notion of high energy involvement in something, activity, advocacy, and fold into a place of rest or a place of calmness. And so the desired equilibrium is a far from equilibrium, robust kind of dynamic.
So you expand a little bit more on activity and advocacy.
Well, advocacy, I'm just using advocacy right now to kind of represent that kind of state of mind that we might be in when we think that the world is full of problems, and we've got the energy and the aspiration to fix the world today. I'm so energized. It's a manic almost kind of state. And then there's the the fold back into, we need a place of rest. We need some calmness. We need to be able to take time off and all that sort of thing. And so it's that dynamic play between the stretch of thinking I could give me the world's problems today and I'll solve them all, versus shut the door and please don't talk to me today because I'm not in the mood, or I'm down and out and I need to break. And that we need that kind of balance in our lives, not a static balance.
Yeah, it's interesting because like in a way, I guess Bucky was trying to solve the world's problems.
Yeah.
I mean, so there's that element of it. So it's um but I guess
And he clearly, in many ways, I think, you could look at different places and times in his life where he was really manic, and other times when he was pretty much down and out and needed to be a recluse.
everybody hits a wall, I guess.
Yeah.
Um and the activity part would be when so that's the advocacy part that I'm a little clear on, and then the activity part, you're talking about the dynamicism of the equilibrium in that particular instance?
Yeah, yeah. And the activity then is that manic, I can do everything today feeling, and the other activity is a rest and let me shut the world off kind of day. And when you think of it in that either or the both and, you can really see that um, stretch and fold are both ands. We need both. um, and it's not either or that um, and it's constant motion, even in, as we've been talking about, the still point of sort of consciousness, but it's still, there's still flux, there's still flow. um, so anyway, that's I guess if we were in actual conversation with Amy, would be like, why did you write it that way? And is that really reflecting what Fuller was talking about? Or um, am I misunderstanding how she's used the word equilibrium and balance?
um yeah, I mean it's a valid question, but I think Steve has his hand
Yeah.
up. Steve, do you wish to chime
Yeah,
in?
I want to just throw in. I have been only able to listen in and out, but there are three words that are of interest to me. I'm absolutely with Richard about the use of the word equilibrium and balance and how they seem to be misused and misconceived things. I have a third word. It's alignment, and so balance is when I create a scale and I just put stuff on equal side to make the two sides of the scale equal up. So if it's real heavy, it's a little tiny mass. If it's light, then it's a big mass. But the thing is balanced. So the scale stays balanced. Then equilibrium, I like the use of the word dynamic in front of equilibrium because it points that there's an equilibrium that's created by this dynamism of the thing, and it's less definable than the balance. And the other one that I like is the word alignment, which is that it's okay the for the masses to be different. It doesn't have, in other words, it in order for it to be in alignment, sometimes it has to be out of balance. And so I'm kind of differentiating between the three words.
Right.
And I think alignment is another word that adds some benefit on it. And then I'm going to go dark.
So was that actually what you were getting to, Richard, in a way, with this dynamism between this activity and advocacy?
Yeah. I mean, the metaphor that or the visual that I've been using with some colleagues has to do with the teeter-totter balance, the balance in the way that Steve just described it, is you put enough weight on each end so that it balances off. And so the teeter-totter, if you want, then sit still. Two people on the teeter-totter, both weighing the same amount, let's say. And then there's the other version of the teeter-totter where you get two sort of different kind of sizes or weights of kids, and they bounce it up and down, and sometimes too much, so that somebody gets thrown off, and then they scrape their knee or that sort of thing. And so when we paint that scenario, then we say, if somebody's parents sent the kids out to the playgrounds for the day, and they came home and talked about being on that teeter-totter in balance all day, and were asked, how did the day go? They probably would say it was boring and I'd never want to go back there. But if they came home having bounced around on the teeter-totter, they're likely to say, we had a great day, we had a lot of fun, I scraped my knee, but that's okay, and I want to go back tomorrow. I want to experience this dynamic equilibrium, if you want.
Welcome, Manu. Has just joined us. It is early in the morning there. I believe it's around 5:30 a.m. So I don't know if you can hear us, but if you can.
I can hear you. Can you see me?
I cannot see you.
I don't know why. Okay.
Well, I mean, it's disappointing because I like to see your. There, well, I see you on the beat.
No, that is, I stopped the video. Let me start it again.
Sure.
My video is not working.
No worries.
Okay, let me stop out and in again, okay?
Sure, absolutely.
All right. Okay.
So yeah, well, while we wait for Manu to join us, does anybody wish to comment on the last line? Fuller's concept of inner transformability. Countless potential shapes and transformations can be systematically represented within this omnisymmetrical matrix. It is a framework of possibility.
Now, what I like about that sentence is the reference to countless potential shapes. And that really creates, in my mind, not a full circle around something, but a really twist and turn, an amoeba-like circle, where it stretches out in some places, it's sort of drawn in other places, and it sort of has a rugged, almost fractal boundary type of shape, and that we can have lots of different shapes. In fact, I've now come to like the idea of, instead of asking, how are you doing, or how are you feeling, or something along that line, is to ask people and ourselves is, what kind of shape are you in today? And somebody might then ask you to qualify, what do you mean? My body shape, my head, my space, etc. And it can be whatever shapes comes to your mind, you can start with that if you want. And it could be one thing or it could be all things. But when you say what kind of shape you're in, it gives you a different sort of story than the question of, how are you doing? How are you feeling? What's happening in your life today?
So Manu has joined us again, and I'm still not seeing your screen.
I have my hand up.
I don't know why.
You have your hand up, Steve?
Put it down. I did put it. I just put it down, but I had it up again.
Oh, okay.
I wanted to comment on that last comment.
Yeah, that's an important line. Go ahead.
I was just contemplating what Richard just said, and I was concerned about my hand being up, and I forgot what Richard has said. Oh, how are you feeling? Okay, so this question, I have a couple comments. This question of, there's a purpose in asking how are you feeling, and then what do you expect? So if I say how are you feeling today, what do you expect from today? I'm asking you to go to your emotional status, most likely, and then shift into more of a logical kind of more idea. Now, and I agree in terms of saying what's shaping up today. One of the things I like to say is what's up for you today. Mm-hmm. If I say what's up for you today, that means if you're coming with a heavy heart, or if you're coming with a heavy brain, or if you're coming physically exhausted, you get to tell me exactly what's up for you today. But I do like the idea of what shape that you're talking about. And this whole concept of infinitely different shapes can result from this. And Richard mentioned a sphere, but what comes up for me is a DNA molecule. And then what comes up for me is a protein. I mean, there are protein chains that have at least tens, if not hundreds, of different molecules stacked together in the weirdest freaking fashions. And that can be any shape. And the most interesting thing for me is similar to what might be called a Planck distance. The isotropic vector matrix is made up of radials that are exactly the same length. Though there seems to be something about quantum and isotropic. So you have this cube octahedron, which is the vector equilibrium. All the radii are equal size, but then they can hook together, like Richard said, in any weirdo fashion. So it doesn't have to show up like a sphere. It doesn't have to show up like a tetrahedron. It can be all sorts of weird tetrahedral, octahedral, polyhedral shapes connected in weird fashions that are beyond comprehension. It's infinite, except that all the radii are equal. And to me, that's very interesting to cope with that, to see that. So I just want to throw that out. So there's my 2 cents on that one, Richard. Good ideas.
Yeah, I mean, I'm gonna see if Manu wants to. I still don't see your screen, unfortunately.
And I don't know. There is something that's not right on my computer here now, because I can hear you, but my picture cannot appear. I turn off and on the video. Maybe Steve can help you. I don't know what's happening.
I don't know. Steve's on his phone today, so I don't know if he'll be able to assist. But
he's a genius. He's supposed to have a solution all the time.
I agree with you 100%. So they should have those solutions, but even geniuses aren't sometimes able to come up with the answers.
Yeah, when I turn on my video, it's just dark. When I turn it off, my profile appears. So I don't know. That's unfair.
So just really quickly to spin you up on a couple of things is that we've just read the end of framework of possibility. And I think that this is a really important part. But if you want to do a really quick check-in, and we can come back and I'll just make a quick comment, and then and if you have any comments on that particular section, because I think it is.
So what did you get? I mean, you give me the gist of what you had. I don't want to mean to interrupt you guys. The framework, that is page what? Page
that is, that's a good question. I'm on a Kindle. Mine says 156, but I'm a little
look for figure 912 and sort of it's in the next page.
Yeah, I see figure 912, yes.
Okay.
And Either on that page or the next page, you'll see the subheading framework of possibilities.
Yes, I see framework of possibility. You read the whole of that already?
We've read the first two paragraphs, right up to invention octet trust, yeah.
Invention of the trust. I see the first two paragraphs end with
So
describing scenario universe.
So the first two.
Okay, I can see invent octet trust. So just go on. I'm going to read that quickly for myself.
Yeah. So actually, we're in framework of possibility, not in. We're headed towards invention octet trust. Anyway, I'm just going to make a quick comment about it. I mean, Richard, you've actually come to this, obviously talking about the XYZ coordinate system and how the, Bucky's minimum system, we've spoken about it, quite often. And so, but I think one of the important things to really consider here is then, if we think about it from that perspective, I think that is the idea that there are frameworks of possibilities. That, and when you're talking about it in terms of the isotropic vector matrix, specifically, we're talking about frameworks specifically when you're talking about the matrix.
I've just gone through it. And can I give my simple thought of it?
Go ahead. Yep.
So the IVM, as she says, is equilibrium, right? That is referential. That is a perfect word. So if you have a concatenation of tetrahedron and octahedron, everything is in equilibrium. But that's a dead word.
Yeah.
Do you understand the meaning of my dead?
Yes. I use the analogy now of a flat line on a heart monitor, dead.
Yeah. Okay. So if it's a dead word, life is energy circulation, energy move.
Right.
Because all of this one, the framework of the IVM and the octahedron, it's a kind of symmetry, and the real world is not symmetrical. The real world is not symmetrical. We forgot about our square, that twist.
Mm-hmm.
So in a world where the square twist, energy flows. Energy always flows. Energy flows to the line of least resistance. Do you get where I'm going to? You have a reference, is a picture, that's what she described here.
Yeah, and that's a framework.
Yes, it's symmetrical, it's everything. So you can measure everything in relationship to that. Okay? So you're going to measure the motion of energy within that system in relationship to that ideal equilibrium. That's why you are going to measure now angles. That is no more 60 degrees. You are going to measure arcs of displacement in referential to the, and she say, in referential to the infinite number of references that you have. That is, each node is a reference. Right? Each node is a reference in the IBM.
Mm-hmm.
So whatever point that you have in the system, you can angularly and arcly determine the position of that in relationship to the node that is closest and in relationship to all other nodes, because all of the nodes are within the matrix. Let me see. You cannot see my screen. I don't know.
Yeah. But
if you took your cube, do you have a cube, Joe, with that stuff, with the magic? Can you build a cube quickly and show it?
I don't have my magnet or.
Richard, do you have a cube there that you can twist like this?
No, I can picture it though.
Okay, so if you find a perfect cube at right angles, right?
Right.
That cube will fit in the IVM, and every node of a cube will be one node of IVM, isn't it?
Yeah.
Because it's perfectly rectangular. It's part of the octahedron, that cube. Now, if you twist that cube, that is, you change it, you twist it, either you turn it or you twist it that way, whatever way, those vertices are going to have turned and move, in terms of distance on a line, right? You can determine it's so I will reserve that for next time. Let me not waste your time, because I cannot see here and it's just very bad. I don't know what. Show adjust.
Yeah, no, I mean, yeah, it's
Joe, if T were there, if you had your magic magnetic set, you could build it quickly. I'm sure Richard has something. Richard, can you show a cube?
Yeah, just a minute.
Yeah.
Carry on talk. I've got to put it together with my magnets here.
Okay, yes. So if you have a cube at the right angle, that cube will fit into the IVM as we describe it there. But if you twist that cube one way or the other, those vertices of the cube are going to occupy a point in space that is not on the nodes of the IVM. That point, each of those points in space, can be determined by the angle of twist and the distance to the closest node. That will determine the position of that node of a cube that is twisted. That is the flow of energy, because now you have a motion within the IVM. You have a reference of measurement and you have a motion of something.
Richard, do you have a?
Oh, I'm getting there. Carry on.
Okay.
Yeah.
That was just a fun as a zest. What she say?
Well, I mean, let me just ask really quickly, does anybody want to comment on the idea, where she states, it is a framework of possibility specifically. Because I think
That is exactly what I described in there.
that's right.
You have a referential,
That's
and
right.
that referential allows you to describe everything within the matrix. The IVM is like is a tensor.
Right.
You know, Joe, in mathematics is a tensor of 12 variables.
That's right.
Huh? That's why you have 144 possibilities of 144 nodes in the most expanded form.
That's right. Yeah, no,
Do you agree with me? Andrew?
You're through?
Yeah, I say the IVM is a tensor. You know, in mathematics, the tensor, right?
Yep. So there was the cube. There's Richard's cube.
Okay, Richard, you have that cube. If you hold it quite rectangular, that is, you know, at right angle, that is a perfect cube, right?
Yeah.
That cube, each of its vertices will be a vertex of the IVM. Do we agree to that? If it's at right angle.
Yeah, it's inside the IVM.
Yeah, because it's inside the octahedron.
That's right.
If you cut the basis of the octahedron on 4 sides, it gives you a cube. If you take the octahedron, right? You take the octahedron and you take half of each of the 8 sides of each of 8 edges, half of it, and then you join them in square. It's going to be a cube, isn't it?
Yeah.
You can draw it. It's simple. If you take the octahedron and then you take half, you know, you cut each of edges by half. You mark the median, the midpoint of each of the edge, and then you link them together. It gives you a cube at the right angle. Are we there?
Well, there's the beginning of the triangles.
Exactly.
On the cube.
Yes. So coming back to my demonstration there. So if you have a cube, that cube, if it's at right angle, fits in the IVM because each point is at midpoint of IVM. Right?
That's right.
Of an octahedron. So it's a perfect, it is in sync with the octahedron. It is congruent to the octahedron. Let me put it that way. Right?
Mm-hmm.
Now, if you take that same cube now, it's still the same cube. It's not stable. And you twist it. What happens? It is collapsing into itself, right?
Yeah.
Remember that those middle points of the octahedron were just lines of flows. Right?
That's right.
So if you collapse it, what is happening? You are causing energy to detour.
Causing energy, I'm sorry, say that again.
To detour. Detour, D-E-T-O-U-R.
Oh, okay. Detour.
Huh? So you're extending the flow of energy. It's no more in the optimum. It used to flow from one vertex of the IVM to the other, all in equilibrium. Now you have twisted it to use a line that is longer, isn't it? If you take 2 vertices of the IVM, they are closest packed, right?
Yes.
They are closest packed. That was the fundamental of building it. Right? Steve is arriving. That's good. They are closest path. Now, if you twist them, that is, if you take one away, you are increasing the line of flow of energy. Do you understand that, Joe? You look very quizzical.
No, I'm following along. No, it's
Thank you.
I'm taking bits and pieces.
I'm saying if Richard, let's just do one experiment. Take two sticks. No, yes, yes. That is even complicated. I just wanted to explain the concept to Joe. Take three.
Thank you.
Yes.
Thank you. Thank you for this.
Take three spheres.
Yeah.
And two edges, and link those in a line. Richard, can you show that?
Yep. I got them linked. Oh, on a piece of paper.
What is happening?
Richard, can you demo that? The three spheres. It's just.
No, I'm saying Richard, I'm asking Richard to do it. If you take three spheres and two sticks, you join in a line so that the two are a line, straight line.
Yeah.
Oh, straight. Okay.
If you take three spheres, three circles,
And
and
just-
Yes, and then you join them. You join them with two sticks.
dot in the middle, and you join the dots, you get a triangle.
No, that's not what I wanted to explain to
Oh, okay.
Joe. I just wanted you to exhibit here on the screen so that I can see three spheres with the line. So three magnets. Yes, with two edges. Join in a straight line.
Like that.
Yes. Okay. Joe, now if you take the middle one and you push it down in something that is elastic.
Okay.
And keeping the first two at the same distance. Imagine that the bond was elastic bond that it could expand.
Yep.
Push it down. Just draw and show it.
Like that.
Yes, but imagine I want the distance between the first outer to remain the same. It's just the middle one that has gone down. You are push it down like with gravity and there's elastic.
Okay. Oh yeah, I mean, it wasn't perfect, but yeah. Okay.
Show that?
Yeah, so it's a little bit, let me get rid of this one. So the bottom one there?
Okay, so yeah, you see in the first line, show again. Show again. When it's a straight line, it was closest path, isn't it?
Right.
Now, on the one that is down, energy, just show again.
Okay.
The length of flow of energy is longer.
Oh, we can see how my blood sugar is going.
I don't know.
Go ahead.
Steve is showing, I don't know who's showing this thing. There is a, like highly, it's just like in space now.
Yeah, it does look like, I was just about to say the same thing.
Okay, I was saying that now, if you take that pink, right?
Mm-hmm.
If you take a photon that was traveling, it will take longer to travel because
That's right.
the longer distance. Huh?
Mm-hmm. Yep.
That's exactly what the cube, by twisting, causes in the IVM. It causes a distortion of line of flow of energy, which now is life. And that's where I say that if you were just the IVM on its own, the world would be dead. There's no life.
Yeah, that's actually something I was just.
Do you understand the analogy?
Yes.
If there was just the AVM, everything will be all close packed somewhere and it will be dead. It will be there, no motion. We're just there.
Well, that's this a fairly easy metaphor of all that is the flat line on a heart monitor.
Yeah, you were mentioning that, and it's important to, to express the opposite of life. It's what is the, okay, we have energy, which is life, and then what is its opposite? It's actually
It's stationary.
it's stationary. Yeah.
Yes. Death is a stationary state.
That's correct.
When you are buried, when you exhale finally, right? And they take your corpse, they put in a coffin, and they put down there, they put it in a hole, they fix you in a matrix in a stable way. That mass is no more allowed, as it existed, is no more allowed to move from a point to another. You get me?
Yeah. No, it's
In the real world.
No longer physically, anyway.
Yes.
it's one of the
And
things.
that's the concept of death.
Yeah. No, it was actually one of the things that I believe the Cyrenaics actually would disagree with the Epicureans on, in the sense that they wanted to basically come to this state of complete balance, if you will. And the Cyrenaics would say, well, that's like death, essentially. They said it was essentially.
But you see when Bucky is in principle say the duality explain everything. The duality fill the whole space.
Yes, absolutely.
Because of everything.
Yeah, it is.
No, if you talk our life outside of this context that we're talking about, the dual, that is what you call death, wouldn't fill everything.
That's right.
But if you define death
If you
as
define
what we're saying here, it fills everything.
Yeah.
Everything is folded into something that you get me?
Absolutely. That's fundamental.
Yes.
That's good. So
we saw that the IVM in total can be collapsed down to 4 tetrahedra and 1 octahedron. Huh? We saw that.
That's correct.
In the most compressed form is 4 tetrahedra, 1 octahedron of volume 8. So the volume of one quantum is 1/8 of the tetrahedron. Do you see where it comes from? Bucky uses that formula many times.
Mm-hmm.
Let me repeat it. The whole world expanded to the vector equilibrium can be Jeter-Berkeley collapse into one original tetrahedron.
That's right.
And that original tetrahedron is made of a duality of 4 tetrahedra and 1 octahedron. So the volume of the original tetrahedron is 8 quanta. You get me?
Yeah.
The volume of a world at its most compressed as the origin is 8 quanta. The 4 tetrahedra plus the dual or the hidden part, that is the implied octahedron of also volume 4 tetrahedra. Do you get that?
Yeah. This is This is something that we covered a few weeks ago, a little.
Yes, that is the whole stuff that we've been studying here.
Yeah.
We've been studying that there are discrete stationary states that are all fractals of the isotropic vector matrix.
That's right.
That's what we have been trying. That's why they are stable. They are fractals of it. We have been studying that if you take the IVM plus the phi of it plus the domain is the whole universe.
Not quite,
Why?
because we're still trying to explain the whole universe in a materialistic way.
No, it's not materialistic. No, because the whole part is the whole Eden part is still there. You just lump it into something. That's what you call the domain. The domain is all the contain, everything that you can imagine.
There is a container.
Yes. So we had three things. The three triangle of life, of universe, initially, is the boundary,
Right.
is the IVM,
Right.
and is the domain.
That's right.
That is topologically the triangle of life at its highest form. The triangle of universe.
And that's how you get to local and macro, right? Or
No, local and macro come from the, that is macro micro. That's what I've described.
Sure.
Is macro micro, the concept. Macro slash micro. That is the whole. It is finite. So the macro micro is made of the boundary.
That's right.
Of this, we're talking of this universe. There are other universes. We don't know. We're talking about our universe. Has a boundary, has the IBM, that is the referential of it. That is the tensor of it, what you call a tensor in mathematics. And then it has a content, which you call the domain. What is in that? So those are the three concepts. Yes, Richard?
But you're working on the triangle, and I was getting some information today from a series of lectures on consciousness. And one of the things that struck out was, or stood out for me, was a reference to four things: space, time, matter, and consciousness.
Yeah.
And when you put them together, of course, in a two-dimensional plane or a three-dimensional sort of form, you have the tetrahedron, and consciousness was simply sort of looked at is what allows us to know ourselves and to know that the universe is contained in us and we're part of the universe.
I have a comment on that one.
Yeah.
You can never put time. You can never put time on that.
That's right.
Time is a derivative.
Look,
it's not at the same level, dimensional level. You talk of things of dimension. Yes.
What I'm trying to say is this is a series of fairly eminent physicists, theoretical people, medical people, philosophers, and I was just intrigued that they put this whole notion of space and time and matter as a triangle, but then they added in consciousness, and when they did that, you get a minimum whole four. That's all I'm trying to say.
Yeah, and Richard's just saying basically the observer again. But one of the things that
and the observer is in the consciousness.
Yeah, that's what I meant.
Exactly. Yeah. I was saying you can argue that consciousness has always been there. You can argue it. That consciousness has been there. Space has been there. And And the boundary has always been there. Because once you put a boundary, the space manifests itself automatically. Once you put a boundary onto something, the space will manifest itself. Do you agree that's Joe?
Yes.
And if you have space, boundary will manifest itself. It is vice versa.
Correct.
Okay. You can argue that at that fundamental level, there was a perverse, when I say perverse, it doesn't mean in moral term, but what you call ubiquitous consciousness. Huh? There is God. you understand?
Right.
So that is at that level, it is a fundamental. If I put myself now on a moral, how will I call it, philosophical ground, less scientific, I'll put that. But mathematically in science, the three that we know is the IVM, is the boundary, and is the domain. That's the way we call them.
Yeah, and
scientifically.
that to me is still another way that tells us we are within the boundary of materialism.
No, it's not materialism. Richard, let me argue why it's not materialism. Because in there is the implied octahedron, which is not, you don't see. What we see, when you say materialism, it translates what people see or people can measure.
That's right.
But the other stuff we don't see even. It has, because we are in the let's just say real phase.
That's the endless possibilities.
Real phase, and we have to wait until what was hidden manifests itself on its own.
That's right.
We cannot force it to manifest. It is a cycle.
Yeah, and that's why we can't.
When summer is gone, when we now in winter, right? You guys are in summer. When my summer is gone, it's gone. I cannot see it anymore. I cannot measure it anymore. I can only expect something else to manifest. Now I'm free to call it summer again. But it looks like it is another pattern that manifests. The one I leave is gone. So
only
people
to return again.
Yes. So people who want to think that the world is just the physical world will describe everything, all their words, in summer.
That's right.
Abstract winter into something that they're not going to take into account, really. Well, what happens? Like in the Bible, it says, those who build a house on sand, when wind comes, it blows it away. But if you build it on foundation, that is, you know the referential, you know the IVM, you know that something hidden is going to remanifest, probably in some form. And I can only accommodate it within the knowledge that all these things come into equilibrium from time to time. Or there is an inherent equilibrium on which I'm not yet navigating. I have to sail. It's like the surfer. You wait for the best surf, best wave for you to ride on the crease of it as a surfer. And down that way. If you're not experienced, you are going to drown because you are going to be taken into the swirl. A surf wave is a swirl, right? We know it instantly. And Richard, Richard, you've been to the tropics. You know what it is. It is a swirl. It is something that is swirling. If you miscalculate it, you are gone. You are sucked into sea and you drown. So that's what the game of life is. There is instability. That is the flow of energy. And our anti-anthropic dexterity is to be able to make anti-anthropic construct that allow us to sail, to build rafters, to be able to save the crease of a wave. Otherwise, we're going to crash or we're going to drown.
Yeah, I think one of the interesting things is actually that, Richard, you keep on bringing up the materialists versus non-materialists. But as we had stated a little bit earlier, is that, there's life and there's death, and you have to be able to state the opposite and understand the opposite. So that's a fundamental, it's.
Well, that's not really what I'm trying to say. From what I've been hearing the other people say, it's not. It's all about
Well,
consciousness being part of materialism, and the whole exercise of the materialists has always been to exclude consciousness, to exclude subjectivity, and simply rest on the notion that if it can be measured, it's real. If it can't be measured, it's not real.
And that's where we were getting with the manifest versus the unmanifest. We were kind of getting into that. But what I'm saying is that you can't say what you can't say what the unmanifested is without understanding the manifest. So
well, that's right, and that's the other thing that was interesting from one of the presenters, an Italian physicist that's been looking at this for many years, was saying that the whole idea of consciousness is something that you connect with somebody else in order to realize your own consciousness, if you want.
correct.
And so it said to me the thing that Fuller talks about, self-awareness and otherness. And if you don't have otherness, you can't have awareness, and you can't have self.
Unity is plural.
And so, but what he went on to say was we create materialistic sort of symbols, if you want, mathematic symbols, measurement symbols, and we use that as our way of trying to communicate to each other this understanding of that sort of ultimate consciousness and who we are. And I found that really interesting because what it said to me right away was that we're using coding and in this case, let's use materialism as a language, as a way to talk with each other. And that translated for me almost immediately into the talking stick. When you're trying to get two or more people to communicate with each other and to do it directly is hard. But when you put a talking stick in, make it available, you triangulate it, then you can talk through the stick to each other in a way that you can't talk directly back and forth to each other.
Richard, what?
So it becomes an enabler.
Right.
The language and the symbolism and the coding becomes a communication vehicle for us to create better understanding between ourselves, and ourselves really is universe.
It's self and other. Yeah, but yeah, I think that what I'm saying is then again.
I just had a representation here. That's actually why Richard was talking. That is actually cool. I think it's cool. I want to share that with you guys. If just draw a triangle, right?
Mm-hmm.
With the vertices domain, IDM, and boundary, right? Have you got that?
Yep.
In the middle of it, of a triangle, make a circle.
Yep.
And call it consciousness.
Yep.
And then draw arrows going out perpendicular to each edge of the original triangle.
Yeah.
It's a cool representation because the triangle is what we measure basically.
Mhm.
And consciousness is the alter ego, that invisible, that stick that Richards was talking about, which come always at 90 degrees. Anything that come at 90 degrees always of the others, what is it? It's precessive, right?
That's right. Oh, yeah.
Yes. And that is a duality here. So you have a duality between consciousness and the domain IVM boundary. That trial. Does it make sense, Joe?
Yeah.
I like that. I just drew it now. It's nice.
That is nice.
We should have Steve put it together nicely. Steve, are you hearing me?
He's on mute. I'm guessing that he's unable to.
But you see the representation, because
Yeah,
that's
no,
what.
I mean, it's. I think
So
that's an interesting way
yes.
of.
So you have this now. This is the word stable, and the other notion that came to me, also quite strong today, is the twist of a cube, of a square, right? To allow energy flow by increasing the distance between vertices. When you twist it, you increase, you turn, and then you move certain direction. So you are creating more distance between the thing, and that's what support the general principle that we say energy flows. Energy always flows. Energy flows to the line of its resistance. In that energy flows, this first representation that we put here, the IVM and the domain, energy is always flowing, right? It's just that it's flowing in a stable pattern.
Right.
Right? That's the referential. You get me, Joe?
Yep.
She said it here, energy is always flowing there, but it's flowing in symmetry, in a stable pattern. Right? Now, if we bring so that is the representation that I gave here of the domain, IVM, boundary, and then consciousness. That is stable. Now, if you come now to the cube of it, you're decomposing, you are starting taking out, the part of it, started cutting the edges, the edges, sectioning that in 1/3, because something always happens. Something come and strike. Right? So if you're always sectioning that, then you start having the elongation and the displacement of a distance of what is required to go from one vertex to the other. That is energy flowing. And energy flowing to line of least resistance. Because if, for example, if this triangle was impacted by a meteorite coming from outside of this world and hitting that boundary, it will twist the boundary, right? Angel.
That's right. It would.
Yeah, the meteorite is going to twist the boundary, and by twisting that boundary, it is elongating the distance between vertices. Therefore, energy is flowing. Energy will flow in this case towards the deepest point of penetration of meteorite. That is the center of gravity of the lowest energy that is there. Does it make sense?
It does.
Exactly. And you do it and it will do that by splashing around energy. The meteorite hit the earth, it penetrates the earth, for example, but at the same time, rocks are going all direction, out. Meteorite in, rocks out. Meteorite in, rocks out. And that is the flow, that is the energy motion. That's what we call life. It's temporary disturbance of the eternal regenerative stability.
Now, let me give you something that's come to my mind out of your sort of this description of energy, or the twisting of the cube, let's say. When you think about precession and you put it in the axis and the movement perpendicular to the axis, and but you can't get movement by just the perpendicular, by the axis by itself. The axis has to twist, and it twists in a zigzag kind of motion or a fishtail motion. And when the points on the axis, let's say two people, or the bee and the flower, when they start to twist, then you start to create motion, energy that starts to move perpendicular to the axis of the twist, back and forth. Just like if you're going to tack across a lake, you twist back and forth. If you're going to traverse down a ski and traverse down a mountain, you zigzag down the fall line.
Exactly.
So
I agree with you,
Does that
Richard.
make sense?
Yes, a lot of sense. And let me correct myself a little bit on that diagram, right? Now, when you take the circle that you put in the middle, and then you take the arrows out that are perpendicular to the edges of the other triangle, that is fine, that's the referential. But this circle doesn't radiate out only in 3 arrows. It radiates all along, right? It radiates completely like a sun. So the arrows going out at all angles. Now, if you take one of the arrows from the center of consciousness, that is not perpendicular to the edge. The distance traveled between that and the boundary or whatever, and the vector of and the edge of a triangle is longer. That's another way of seeing it. You see what I mean? It's longer than that of the one that is perpendicular to the edge. Do you see, Joe?
Mm-hmm. No. Well.
No, you can draw it. Joe, draw. Take your draw what I say. Take. I have it here on my stuff. Draw the 3 triangles of the one triangle of domain, IVM, and boundary. Draw it. Make it big a little bit.
3 different triangles or as a triangle?
No. Domain, IVM, and boundary are spheres.
Yeah.
3 spheres making a triangle, linked to a triangle.
All right,
okay. Yeah. Okay.
Another piece.
Have you got that?
Yep.
Now, on a different color now, put a circle at the middle of that triangle, Joe. Your thing is going to be the one that will exhibit.
Yeah, and that's the...
Like what I call consciousness here.
Consciousness.
Okay. Okay. Now, draw arrows out. First, draw 3 arrows on one color that are all perpendicular to the edge of the original triangle. Of a different color.
I don't have a different color, but...
Okay, yes. Have you drawn it?
Yeah.
Now, draw other radiating out, other arrows in dash. That goes not at 90 degrees to the edge. Just draw a few.
There it is.
Yes, Richard. Okay. So you can see that if you go at 90 degrees, the distance from consciousness to the boundary to the point is shorter than that if it's not at 90 degrees.
That's right.
And that's
the distance to the edge is different than
that is the energy flow. Yes, that's life. Yes.
And that's the distance to the vertex.
Yes.
Yeah.
Okay, so that illustrates a little bit the flow, what caused life. That is a temporary disturbance. There's always So you can also make an analogy that that arrow that is perpendicular is how the meteorite hits the globe, for example. And the one that is going a little bit skewed toward the thing is how the material are flowing out. So you always have that duality that is at play in everything.
Right.
That has been my experience, always.
And that's the key. The duality is absolutely in everything.
Yes, everything, everything.
And that comes back to the whole idea of life and death being something.
And I found that by accepting it, it makes it easier to read this scientific or to pick up where something is missing.
That's right.
Because if you are of the school that time is a fundamental dimension,
right,
you always come short. Because you always introduce time with things that don't work together. It's like taking the seed and the fruit. You see, if you take an apple, in the middle of an apple, you take the seed of an apple. And then you are saying that you are mixing now the apple and the seed in an external relationship. It can never be. The seed and the apple are always in relationship internally. Because the seed is in the apple. You get me?
yeah.
The seed is the consciousness of the apple. We eat the domain. We eat the IVM of the apple. That's what we eat.
That's not what these people are seemingly addressing now around the whole study of consciousness. They're not saying the seed is the consciousness of the apple.
No, this is just a metaphor.
No, I know that, but
yeah.
But what I'm hearing them say is the seed is, if you want, the consciousness of the apple, and the apple is consciousness in itself. It's not an either or. It's not the two things in a sort of duality.
Yeah, but what comes first in that process?
No, the two are together.
What comes first in the way that I'm now hearing and listening and to these people talk about is consciousness comes first.
So consciousness is primal, right? If consciousness is primal, you cannot compare it. You cannot put it in that type of relationship, lateral like that, with the apple. Consciousness was there before.
Mm-hmm.
And it was there with something. What was it with? Remember that fundamentally, there's no one. There's only two in one.
That's right.
That is the fundamental of every construct.
Well, in that sense, you see, the people they're also starting to say that consciousness is, if you want, that great mystery, the unexplained sort of mystery. We can get close to it, but we'll never grasp it. And so,
yes, I agree.
When we try and take consciousness and then turn it into a thing like God, then we're misusing what's starting to become an understanding of consciousness and how it can be part of if you want, materialistic science.
I mean, Richard,
that is just a way of it. I don't want to go into that debate because it's not important for our understanding.
It is important. I've just listened to some of 5 or 6 very eminent people who are exploring and learning and pondering about consciousness and science, and in that sense.
And so let me ask you this.
You know, the history is full of eminent people who are fools at one point. I'm not saying they're always fools.
Well, then
so let me ask you, Richard, actually.
You can't dismiss, anyway, okay, fine.
It's not a question. It's interesting, Richard. I mean, because, you know, this is, because I think it is important, but what do you think the importance is?
Of what?
What you just were saying a moment ago about the idea that describing consciousness as where there is a unmanifest versus the manifest.
No, it's just there.
Right. So what's the implication then?
The implication is it's the mystery of the universe. It's who we are. As one of the fellows was describing today, the universe is in us, and in order to try and understand that, we connect with somebody else, let's say, and the universe is in them as well. And then we begin to, through consciousness, begin to know ourselves. And in doing that, we begin to know the universe, because the universe is us.
And so when you say know ourselves, does that mean we have that we're self-aware? Then you're saying that we have choice.
I don't know whether it's saying whether we have choice. So I'm saying that
because I mean,
again,
I
I'm trying to say again what Fuller is saying is that in order to know us, there has to be otherness.
Sure.
And
I think we've established the duality aspect of it. I mean, and we talked about it.
But it's not duality in the way that we normally think of duality.
But the idea is like you can't have life without death, right? So that's why when we're stating that you have to have that opposite. But my next question is that okay, now you start to know that your consciousness, what is the implication then? What does it mean to be conscious in a very practical sense? So does the idea that we have autonomy over that domain? And I mean, that's a very deep question as well. So
no, well, for me, it's not.
Because that's why I was asking you even first, what comes first? Like with the idea of us understanding, us perceiving the world or the world itself?
Well, I mean, this is where we get into the separation issue, and the idea of us perceiving the world as if we are outside the world. And what I'm hearing these people now talk about is that there is no separation in that sense. It's Bohm's undivided wholeness idea, and consciousness is there. It exists. So in that sense, they seem to be arguing consciousness, in a sense, doesn't come first. Consciousness is just, well, I guess in the way we're trying to symbolize it and talk about it, we're saying consciousness comes first. And a lot of people try and say, well, where does the consciousness come from? Does it come out of the brain? Does it come out of the heart? Where does it come from? And the turnaround of that discussion apparently is more along the line of, it doesn't come from any of those places. It is, and it's in your head, it's in your heart, it's in your body, it's in your being.
I agree to that, Richard. And scientific
and
discovery.
it also fits with Ubuntu that says, I am because we are.
Yeah. And scientific discoveries are supporting that. We know that the brain is not only in the head now. We know that the brain, as defined physically, is actually at least the brain that we know plus the TI. That is the throat to intestine. There's a whole tapestry of nerves that are all linked. Right?
Yeah.
So that also is the seat of consciousness. So consciousness permeates this physical body completely, as we represent here. It was there before it permeated. It is radial to this body that is closed. Consciousness is within and goes out.
Right.
Are there degrees of consciousness?
Yes. And that's why the discovery of consciousness and education as it's called, educi in Italian is to draw out. In Latin, educi, to draw out, like drawing out of a borehole, of a well. So education is the facilitation of that drawing out, of helping that consciousness of the individual to radiate, to show out.
And that's where it's getting to like a more fundamental part of this is that, you know, we have these discussions because I think that it's important for a lot of different reasons, but one of them obviously is to say, well, conscious or unconscious. Like, I mean, like it's there's degrees of consciousness, there's even degrees of awareness. And understanding that is actually fundamental. Because it's actually, and it's important for a lot of different reasons. One being moral responsibility, which is actually key. So, I mean, that's one of the reasons we have in the first place is that you're able to state the opposite. You know what it is and it isn't. What exists as far as how conscious is an individual and how much autonomy do they have over their choices. And that's one of the reasons why you have a conversation about consciousness to begin with. So that's what I was trying to kind of, you know.
Well, the other sort of addition to that too, though, is that if you know, this what is and what isn't, that opposite idea, which is assuming that there is something explicit that tells you what is and what isn't,
right,
or what the opposite is. But then when you come into something like fuzzy mass, then you start to get the blurring. It's you know, 90% is or isn't, or 99%, and that's where you get that idea of the different kind of stages of say consciousness in the way you were describing it a minute ago.
well, I mean,
So
there's different stages.
you acknowledge the fuzziness of the boundaries.
Well, that's correct. And the fuzziness of the boundaries is based on awareness. So the idea that even what you were coming to, the, you know, this idea that there is an awareness that I've talked about here in the past is that the awareness of a child and the awareness of adult is fundamentally different. And, you know, there's that idea that as a child, you know, you have a very limited understanding of, you know, the other. But then there's kind of growth that you become more aware of the other. So, and there's that awareness that actually leads to understanding. So,
yeah, well, but as you say, the going back to, if you want, first principles, the principle doesn't change.
no,
It's
no, it
still
doesn't.
it's still
But
self-awareness other.
and that's one of my points is like material versus non-material, the unmanifest versus manifest, and you have to be, or death versus life. The idea that you're able to spot or you know, distinguish between the two is fundamental. Like that's full stop. So, I mean, I think that that's an important part when we're talking about this as to a starting point and then the meaning between it.
Yeah, and that seems to come close to what Bucky was trying to say is awareness.
Correct. And how much awareness is relates to cause at a certain point.
And I remember one exercise he was showing in terms of that little kid is in terms of coming to an understanding of their otherness is you start with their own otherness. In other words, the parents and others will say, they'll point to the ear, the eye, the nose, the mouth, and get the youngster exploring the extremities of their own body.
Right. And what I think that there is this other aspect of it, even as you get into the idea of reductionism versus where there's a either a reductionist or you're somebody that, or you, the idea of downward causality comes into play.
But let's just put it this way: consciousness is anthropic, right?
Right.
Consciousness is anthropic.
That's
We
right.
saw it here. It is radiative. It's everywhere. Awareness is anti-entropic.
Correct.
It's what?
Anti-entropic.
Anti-entropic. Through our senses and with the help of each other, we become aware of consciousness. And that's what Bucky was saying.
That's the both end.
Yes. And that's why Bucky say life starts with awareness.
That's right.
Awareness of the otherness. So life is inherently unstable.
Correct.
Okay?
Now, how do you make that connection?
That life is inherently unstable because
Yeah.
it changes all the time.
Right.
Yeah, okay. Well, in that sense,
It's a circulation. It's a circulation. Let's say that you
Yeah.
tag.
let me
That's
come
like
back.
You tag
like-
a photon. You tag a photon, which is an energy, one elementary, one quantum of energy, 1/8 of it. That you tag it now. Next is no more there. It's something else. So it's unstable. The motion of that thing is always moving. Unstability means moving.
Yeah, well, that's what I'm trying to get, going back to the chaos theory sort of understanding is unstable is the equivalent in the way you've used it. Unstable is equivalent to robust. It's always moving.
Unstable.
Well, robust is unstable in that sense. It's going
I
back.
wouldn't make that. I've not yet made that leap.
Well,
Yeah. I'm
read
still-
chaos theory, and that helped me.
yeah,
and
you applied
that's-
chaos theory to
that's-
that one.
That's
Yeah.
why the stretch and fold idea came in, which is movement.
Is that where you?
Yeah, robot. Yeah. Well, I mean, I see your link because I say it's anti-entropic.
Yeah.
But that is at the general topological level. Now we have to be specific on what we're talking about when we go to a compartment of it. It's much more general. What I see there is like the equivalence of mass and energy. But if you want to talk about magnetic energy or electric energy or gravitational energy, it has rules, its own rules.
Well, we're coming up on the hour, so we can decide whether we're going to read a page, read a little bit more, or
See, we read. We are not many. We read, and then at least we progress. Because I'm the one who came with all of this disruption.
Yeah. Okay. All right. So why don't we read a little bit more? And then we'll go to takeaways, right? So we'll make a little bit of progress. And if we have to come back over it, we can come back over it next week. So oh, hang on. Can everybody see my screen?
Yeah.
Okay. Our familiarity with the IVM enables us to visualize and appreciate Fuller's octatrus, awarded a U.S. patent to 2,986,241 in 1961. This structural framework is so widespread in modern architecture that one might assume buildings have always been constructed that way. Again, as the story goes, the invention can be traced to 1899 when Bucky was given toothpicks and half-dried peas in kindergarten. So extremely farsighted and cross-eyed that he was effectively blind until he received his first pair of eyeglasses a year later. Bucky Fuller did not share the visual experience of his classmates and therefore lacked the performed assumption that structures were supposed to be cubical.
Wow. Wow.
Right. Oh, damn it. Yeah, that is interesting. Thus, as other children quickly constructed little cubes, young Bucky groped with his materials until he was satisfied that his structures were sturdy. The result, much to the surprise of his teachers, one of whom lived a long life, and periodically wrote to Fuller recalling the event, was a complex of alternating octahedra and tetrahedra. He had built his first octatruss, also the first example of what was to become a lifetime habit of approaching structural tasks in revolutionary ways. The experience had a great impact on the 4-year-old. As he recounted in a 1975 lecture, all the other kids, the minute they were told to make structures, immediately tried to imitate houses. I couldn't see, so I felt, and a triangle felt great. I kept going till I felt right, groping my way. That's the end of the quote. The truss omnisymmetrical triangulation distributes applied forces so efficiently that the resulting strength of such an architectural framework is far greater than predicted by conventional formula. The unitary systematic non-redundant octatruss complex provides a total floor system with higher structural performance abilities than engineers could possibly ascribe to it through conventional structural analysis, predicted only upon the behavior of its several parts. 650.11. Struts can be all one length, thus simplifying construction, while the minimal volume to material ratio inherent in the geometry of the tetrahedron maximize resistance to external loads. The intrinsic stability of triangulation together with efficient dispersal makes this system the most advantageous possible use of materials in a space frame configuration. It is axiomatic to conventional engineering that if parts are horizontal, they are beams. And the total floor ability by such conventional engineering could be no longer than the single strongest beam in the plural group. Thus, their prediction falls short of the true behavior of the octatruss by many magnitudes. That's 650.11. The octatruss takes the conceptual matrix into physical realization and thus embodies Fuller's design science of using geometric principles to human advantage. We can now appreciate the difference between diamond and graphite. Both consisting of carbon atoms, the former is exquisitely hard and clear, the latter soft and gray, and their differences are due to geometry. Carbon atoms in the structure of diamond take advantage of the strength of tetrahedra. Their organization can be thought of as a double octatruss, two intersecting matrices with the vertices of one overlapping the cells of the other. Stabilized by the high number of bonds between neighboring atoms, which also allow forces to be distributed in many directions at once. The configuration is supremely invulnerable. In contrast, the carbon atoms in graphite are organized into planar layers of hexagons triangulated and stable in themselves, but not rigidly connected to other layers. As a result, separate layers are able to shift slightly with respect to each other, which does not mean that graphite lacks all stability, but rather that it is relatively soft. Okay, that makes sense. This softness enables graphite to leave visible residue on the surface of a paper, thus performing its useful function in pencils. A more illustrative, although less widely recognized application is that these sliding layers make graphite a powerful lubricant. The comparison provides a spectacular example of synergy. Rearrangement of identical constitutes produces two vastly different systems.
Guys, did you understand that?
Thus we see that, let me finish. Thus we see that nature also employs design science.
Wow. Did you receive what I sent you? I sent it on WhatsApp, on WhatsApp group. Can you open the WhatsApp? Maybe I can share it here. I just sent it now.
You just sent it now?
Yeah, you should receive it. Let me see if I can open my WhatsApp on my computer here.
Oh, yeah.
Okay, do you see that?
Yeah.
Okay, what is there is the geodesic dome built with paper. I've always put it, sometimes I put it on my as a hat here. You know that? It is solid. When I press on it, it's solid. And this is paper, just simple paper. That is what they make analogy here in terms of diamond strength over carbon, relatively. Now, the second thing that she was talking about, where in the graphite is in sheets. Graphite is like clay, right? You know that clay, if you know clay has two properties, come in two forms. In oil is very important. You have sheet clay, organized in sheet clay, that is ductible like this, and is used as a trap. It traps hydrocarbons that want to migrate upward. It traps them. And then you have clay that is dispersed. And that clay dispersed retain water. For example, you had high blood pressure. Some of the time, it is because there is in your bloodstream salt that retain water. And the retain water that increases the volume in your bloodstream and presses against your arteries to increase your blood pressure. That's one of the sources of blood pressure, especially of Black people. Black people people of African descent. They have that problem. But what is here is that when you come to the graphite now, which is organized in sheet, do you see the relationship between sheet and the cube? And the plane face of a cube? And that is used for writing. You make the analogy of writing, that application of writing and the flexibility of cube? If you try to write with a diamond, that the diamond will cut everything.
Right.
If I take a diamond and I use it on my sheet of paper, it's going to tear it.
That's true.
Diamond cuts. If I take graphite, which is the same carbon atoms, just organized differently, and I write it, I slide it on the paper, it's going to leave a trace that allows me to read. Again, that flexibility, the association of a triangle and a square. of a tetrahedron and a cube. It's always that.
Really quickly, what is the material that you're using there?
Paper.
It doesn't look like, it looks like something.
It is paper and glue, simple. I use paper, glue, and scissors, finish.
What kind of paper, may I ask? It just looks really thick.
Any paper will hold. Any paper,
Okay.
even the that you print. This one was a paper where you say, for example, you want to print invitations.
Yeah, that's what it looks like.
For a wedding. That type of paper. That's what I use here.
Yeah, that was
but any paper will hold. What I'm trying to show there is that the multiplicative effect of the bond that you created, right? Did you see on that? Show it again, Joe.
Oh yeah. Let me pull it back up.
Yeah. Do you see the twisted squares and the triangle association on this? Do you see the twisted squares?
Yeah.
So if you take F9, face 9, and the other one on top of it.
Yep.
The contour of it is a square now. Is a square that is twisted to make a rhombus. Take F9 and on the top of it there is that brown piece triangle that is on it. If you take the contour of it, it's a rhombus, isn't it?
It is.
Now, if you take F9 and F10, how are they linked?
How are they linked?
Yeah, vertex to vertex.
The bow tie. I mean, it's
vertex to vertex.
Right.
Yeah. On one, you have two triangles that are bonded on an edge that have a bond of a liquid. You understand? Bucky make that analogy.
But you
On
got 20
one.
triangles there, right?
Yes. I have 20. I have, let me count here. The white are.
You got 10 around and 5 on the top.
I have 10 whites.
Yes.
Yes, I have 10 whites. And then the other one are pentagons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 times 5 is how much? It's 30. 30 plus the 10 is 40 in total. So when you divide by 2, it's 20. That's why you say the icosahedron and the rhombic dodecahedron are of volume 20. You remember that?
Mm-hmm.
If you count, you see the octahedron, that the pentagon that are there. You see them?
Yeah. So if you got a icosahedron there.
The number of pentagon is 1, 2, 3, 4, 5, 6. There's one at the top, and then one, and then 4 around, 5 around. No. 1, 2, 3, 4, 5. 5 around and 1 at the top. That is 6. Each has 5 triangles. 6 times 5 is 30. And then you have the white. White are 10. And the white, so 10 plus 30 is 40. But remember that this is a sphere, because one is in the order. You have the concave in the convex. Yeah, the white is convex. The pentagon are concave. So what you have is that the total is 40, and then when you are calculating for one, that is half in the real world, this half hemisphere, the volume of the octahedron that is made of icosahedron, for example, that is made of this 10 triangle like this, link like that, is 20, is half of a total of 40. So if you look at Bucky, his explanation, the volume of the icosahedron is 20. The volume of the rhombic dodecahedron is 20. and the two have different number of vertices and faces. But the combination of those give the same volume. But what I wanted to show here was basically the bonding part of it. You see, between the white part, the bonding is vertex to vertex. Vertex to vertex, that is a gas.
That's right. And it's unstable. It's volatile.
Yes, yes. And then between the white and the part and the triangle, the adjacent triangle that is part of a pentagon, it is a liquid bonding. It's one edge. It's double bond. And between parts of the pentagon is multiple bond. That's what gives you strength. So the association of the flexible, that is gases and liquid and solid, gives you a combination that is functional, that is strong, and that is it. Because those F10 in Bucky's construct will be windows of apartments. F9, F10 will be windows, doors of apartments. The solid side, the pentagon, will be the cupola on top of it that gives shade from the radiation that comes from outside. So you can see through and you are sheltered. See through, sheltered. You see the very different, I mean, there's so many applications of this thing. That's why I always say that if you can do it, and I gave it to Steve. I always wanted us to do this exercise. And the people who are there, used to be a lot of people in this group. As soon as we showed this to start doing it, they ran away.
Mm-hmm.
They didn't want to make the effort. But it's very doable because there are ratios between triangles. You see, the triangle of the pentagon are isosceles, while the triangle of the white there is equilateral. So you have association of isosceles and equilateral in a certain ratio.
Okay, so
I'll tell you my curiosity of that section right now.
go right ahead, and then we'll go to our takeaway.
Well, here we are, Amy, writing this book in the late 80s and the early 90s. And in 1985, we had the discovery of carbon-60. So we have the third form of carbon, which up until then, everybody says it's impossible. There's only two, graphite and diamond. So I'm curious as to why she didn't include some reference to carbon-60 in this particular, or in the writing of her book, in this case, somewhere around 1990, 92, I think.
I think that because there was still controversy.
Yeah.
You know, when you make a discovery, for it to become permanent, it takes a long time. Eh?
Yeah, well, the literature says it was between 1985 and 1990.
Well, she does mention it in the book, so let's, you know.
Oh, does she? Okay.
Oh yeah, multiple times. It's in the it's preface. So, but anyway, we can come back to that later.
Okay.
But you know
okay.
Yeah, I mean, so that's something that's. I mean, I can give you the pages if anybody wants to.
I was looking at
I see that she put at the end of it. Thus, we see that nature also employs design science. No, nature always employs design science. Nature is always smart, always.
Yep.
And we learn from nature. It's not that nature also employs. It's always.
We are of nature.
Yes.
So
So my statement would be nature always employs design science. That's where the people, you know, like when you do your meditation, you say everything happens for a reason. Why do you say that? People say so. Everything happens for a reason. There's no gratuity.
Say that again. There's no what? Gratuity?
Gratuity in nature. Everything happens for a reason. Gratis doesn't exist in nature.
I guess that means that that as we are part of nature, that we are behaving in the way we behave for some reason.
Yes. That's my belief. For some reason. Because there will be consequence. Since we can't say that it happened before, we can also, it's also easy to accept that it happened before. So there's a reason. There's a causal effect. The fact that we don't grasp it doesn't mean that there's no causal effect. And that's the limitation that you see, you put into science, Richard, you're always talking about it. Because we can't measure it, therefore, it doesn't exist. No. Because we can't measure it, is because we can't measure it. Let's accept our limitations.
Yeah.
Yeah.
But classical science doesn't want to accept that limitation. It wants to get rid of it.
Well, okay, so
and that's what the debates are now about.
We're going to go to takeaways, Richard. So, actually, why don't you get us started since you already were going into.
Yeah, it's interesting. I looked up in the index of the book I have anyway, and it refers to carbon atoms and carbon fiber, and
if you look in the chat, actually, I already put the quote that she talks about it in the preface.
In where?
In the chat.
I know, but where does she talk about it?
In the preface.
Oh, in the preface.
Yeah.
Okay.
We covered the preface when we first started the book.
Yeah.
So,
okay. So she basically just says hello to it then. Yeah.
Well, I mean, I could read it. The recent discovery 60, a carbon molecule that's a tiny replica of Fuller's geodesic dome, provides an apt illustration. And naming this new molecule Buckminsterfullerene, scientists Carl Kroto and Richard Smalley have lightheartedly acknowledged a debt to Fuller for enabling them to identify this geometric configuration occurring on a scale far too small to be seen directly. As a result, almost a decade after Buckminster Fuller's death, his name can be found in some newspaper.
Is that the Fullerene?
That's right. That's what he's talking about.
The Fullerene. Yes.
Fullerene.
Yeah.
Yep, can be found in a newspaper or magazine on a weekly basis due to CCC's far-ranging for scientific. So yeah,
Fuller did not discover it, but his concept and his teachings were so influential,
correct,
that the discoverers gave it the name.
So go ahead, Richard.
What's that?
You're going into your takeaway.
Yeah, no, I mean, my big takeaway is the continued sort of dialogue around, for me anyway, around this whole question of how we appreciate the notion of equilibrium and the different ways in which I've learned about it, and originally it was that static teeter-totter sort of balance that you have to get balance between work and play. And when I became aware of the chaos theory literature in the late 80s and 90s, it gave me this other side of how to look at equilibrium. And it talked about death, if you want, as being ultimate equilibrium, like the flat line and the heart monitor, and a robust equilibrium, which they call far from equilibrium. In other words, you want to be as robust as possible during your lifetime. And then, as you said, the opposite would be sort of to return to the soil, to go through death. And so this whole idea of a robust equilibrium, the bouncing back and forth on the teeter-totter, became really important to me. And it's really important in terms of the notion of working hard and giving rest time, and the notion of employers, not driving you to exhaustion with the whip if you have to keep, working for the employer. And we don't care about your off time or your rest time. And so I think there's still a kind of a open discussion around how we use the word equilibrium and what it means in terms of the kind of health of a system, and I'm becoming more and more aware and appreciative of this whole question of consciousness and how it is being addressed, and how it's been excluded from classical Western science, and now it's starting to be examined and appreciated by some fairly significant people who have spent their lifetime looking at physics and biology and that sort of thing. So this helps me get more and more out of the other things that I listen to. And as I said, I guess a takeaway for me is the continued curiosity as to why the work of Fuller never really surfaces in some of these discussions. And yet his work is, as I listen to these other people talk, his work is front and center in almost everything they talk about. And the other big takeaway for me is that when I sit in their midst on a screen like this, I feel that I'm following them, I'm understanding them, I'm saying, hey, I've been there, or I've been in dialogue with my own colleagues about the same thing, which would make me less frightened to sit in their midst at some point if that opportunity ever presented itself, and just soak up what they have to say, and maybe be able to contribute something at some point in the dialogue. So Manu, how are you feeling? What are you taking away?
I feel quite good. I think that tonight we really went deeper, and I really appreciate all the contributions. What I take away is a few points. Is that consciousness is dual to domain, IVM, boundary. I also take away that awareness is anti-entropic to consciousness, because consciousness is radiative. And I also take away that life is inherently an unstable flow, and that death is stationary life. Those are my takeaways. Is Steve on? Oh, no, Steve, no. So Joe, how do you feel? What do you take away?
I'm feeling good as well. I'm just actually looking at one of the papers Richard sent us on chaos theory that he'd written, where he links it to mission and values, but that was a while back. But anyway, Yeah, no, I mean, I very much appreciated tonight's discussion. I really liked the fact that when we put together the idea of the boundary, the domain, and the IVM, I thought that that was a really good, kind of way of looking at it, how to understand a whole system. And kind of also brought some new ideas to me as to what the IVM actually meant. And as I dive a little bit deeper into that, that's really interesting to me. I mean, it's fundamental, I should say, not just interesting. I also find it our discussion of consciousness and awareness to be enlightening. Been in a lot of discussions about consciousness recently, and what it even means to be aware. It's not just to say awareness, it's to actually understand what its implications are. And so, and those discussions are actually, as I'd mentioned, even on the onset, that those conversations are much more important today because obviously we're asking, what is it fundamentally that makes us human? And so, and I think, some of the illustrations that we went through were really important. And I've been thinking about this in terms of, we've talked about the connections between objects and structures themselves. And there's an interesting hypergraph that I was looking at while we were here, actually, that I brought a little bit more context to me. Also like the idea of anti-entropic and entropic, the way you work that in Manu. And it's really good to kind of revisit all those concepts. So even if it sounds like we're repeating ourselves, it's not without value. In any case, I will leave it there. And I'm looking forward to seeing everyone again next week. It's currently the 20, it'll be the 22nd, it's the 15th currently here. So I don't know if it's actually reached the 15th quite where you are, Richard, yet. But anyway, look forward to seeing everybody in next week. Thanks for joining. Thanks for making the effort. I know it's early there. I know it's late where you are.
But I think one very important thing that we have to do, and because of it, is that because of how we've been educated, is the importance of a square, of a cube, of a rhombus in the energy flow.
Right.
When put together with the triangle, the octahedron, and the tetrahedron, it can provide very powerful ways of designing. You can design something very strong, or you can design something that is very, very flexible to serve a certain purpose by combining those two. So every state of flow of energy, that also come to one thing. We say that everything in the structure, that is every point in the structure, can be reached in the structure of universe, because universe is at least structured in part. In that structure can be reached by a rational combination of the octahedron and tetrahedron. You remember that?
Oh yeah. And we're going to get more into that actually in a couple of weeks.
Yes.
Over the next couple of weeks.
That is to say that, all our ratios within are non-transcendental, even if they cannot be reached. The only time that you talk about a transcendental thing is when you are defining a sphere. That is, we know, we are imagining what we live in. We don't know what, we call it a sphere.
That's right.
Because we call it a sphere, we have to have a device to measure it that is transcendental. That is, it does not abide by the rules of our structure. It transcends it.
Right.
You understand what I'm trying to say?
Yeah.
So that's the way. That's the same thing when it comes, for example, to the basis of count. When you take logarithm of exponential, you take logarithm of base A, B, C, D. You have the natural one that is called E. You remember E? The Neperian number. When you say exponential, exponential x, exponential 2, the value of that E, that is 141 something, I don't know what it is. It is one, is like pi. It's transcendental. You see what I mean?
Yeah, I actually do.
Because it is the base of our counting. So pi and E are duals that we conceive that are transcendental. Do you see how? Pi defines the sphere in which we are, our bubble, right?
Yeah.
And E is the basis of counting what is inside.
Okay.
When we take the fractals and we say logarithm or exponential, because logarithm and exponential are dual also, you know that, right?
Yeah. No, I do.
Do you know it? The logarithm function and the exponential function are duals.
That makes sense.
It's not the sense, that's by definition. They are
Yeah,
duals.
No, I mean, there's a paper that I'm reading that actually helps with.
Because we commit the same error in counting within our system by adopting a decimal counting system. That doesn't allow for multiplication or division naturally. It's the same thing that we're talking about in terms of the referential. When you take a fixed referential for something that is ever regenerative, ever changing, it cannot work. You see what I mean?
Yeah.
So we see that most of the time, to count real thing, you have to change the basis to go to a logarithm or an exponential basis. But logarithm and exponential are the same. They are the transform of the order. They are in a dual relationship. You get me?
Yeah.
Yeah.
I'm actually.
It's like to say exponential thing and square root. You get me?
I am actually
Those are dual. Dual means that the multiplication of the two is 1. Exponential of log of something is that same thing. You know that function, huh? We do in mathematics. If I say log of 10, and I say exponential of logarithm of 10, it is 10. Did you know the relationship?
I do now that you're
Yeah, you can calculate it, whatever. Exponential of logarithm is 1. What does it mean that 1, when you multiply the 2, it gives 1? What does it mean?
Repeat that. I'm sorry. I was looking up something.
Okay. You see the logarithm, right?
Yeah.
And the exponential.
Yes.
Take any number. Take 2, for example.
Yes.
You can calculate exponential of 2.
Correct.
If you do logarithm of exponential of 2 is 2. If you do exponential of logarithm of 2 is 2. Huh?
Okay. Yes.
It means that by multiplying, by putting those two in a precessive way, by multiplying the 2, it gives 1,
Right.
which is the definition of duality.
Right. Okay.
The 2 together give 1. If you ever did set theory, in every set,
Sorry.
there was what you call the inverse of a number, right? In set
Right.
theory. And then what you call neutral element, that is the 1 of a set, was the multiplication of anything by its inverse. It gives 1. The inverse of 2 is 1/2. You multiply 2 by 1/2, you have 1. The inverse of 10 is 1/10. If you multiply 10 by 1/10 is 1. Right?
Mm-hmm.
So the neutral element or the base of that system is 1. You
That's
get
the
me?
neutral element.
Yes. Yeah, you have the neutral element and you have what you call the absorbent element, that is 0 of a thing.
Right. Okay, the absorbent.
So because everything that you compose with 0 give you 0 is the absorbent element of a set. That is a set theory.
That's something I need to learn.
Yeah, go back to your math books.
Yeah.
High school. Okay, excellent. Otherwise, I'm very grateful. Yeah,
This is
I
very
think
helpful.
that there were some really powerful ideas that we discussed here. That's the beauty of
Very good ideas.
putting minds together. You know, you have a multiplicative effect that can be very powerful, sometimes even scary.
No, I mean,
Now,
yeah, even
yeah.
no, a lot of the stuff that we've been covering here, and even you know, some of the things that even Richard was talking about with language itself and how that relates to awareness. I've actually an interesting diagram here, and I could share with everybody, but it's about latent representation. But I just actually appreciated what you just shared there a moment ago. Manu, that was really helpful. Yeah. Anyway, there's a lot to recall when it comes to the mathematical aspects of it that I'm kind of going through some basic forms of it right now. So, but yeah, no, these were really some deep concepts we covered today. Yeah, I appreciate you, Richard, bringing in those other discussions that you are in into our conversations. Those are good. So, and I think we got back to some fundamentals as well. Basically self and otherness. So, you know, some of those, you know, we have to say what something's not. So, in any case, I'll see everybody next week. And then, yeah, if anybody wants to copy what's in the chat, go right ahead. But if not, it'll be out and it'll be in the that Steve sends out.
Okay, but I want everybody to get also out of here. What I say is that pi define our macro is the link between us and our macro, and E is the link between us and our micro. So pi transcends our structure to the macro, and E, the basis of what do you call it, of exponential, the Neperian number. Yeah, is the transcending towards our micro. We live in between.
That's right.
Mhm.
We're in a matrix. I'm just writing that down actually. But all right. I have some things to I have a lot to look forward to this week. So in any case, looking forward to seeing everybody next week.
Yes.
Take care.
Yes.
I know.
Bye bye.